earlier video, we discussed some properties of the Dirac delta function. We underscored the fact that the Dirac delta function is an even function, implying that it is not bothered about the sign of its argument, and that if we push a negative sign into its argument, that is, change x to minus x, it holds on to its value. Such change in sign does not have any effect. Having established that the delta function is an even function, it is now time to ask, what about the first derivative? Let us start with a question, and the question is, show that the first derivative of the Dirac delta function is an odd function. Let us answer the question. Let us consider first the definition of the Dirac delta function. And we know that Dirac delta function of x is 0 for x not equal to 0, and it is infinity for x equal to 0. And this occurs in such a way that the area under the Dirac delta curve is unity. We now multiply by x, and this gives the left hand side to be x into Dirac delta of x, which is equal to, for x not equal to 0, x into delta x, x not equal to 0 multiplied by 0, because Dirac delta is 0 for x not equal to 0. So the product is 0. And for x equal to 0, we have x Dirac delta of x equal to x is 0 multiplied by infinity, which is the value of Dirac delta at x equal to 0. So the product is 0 again. This means x into Dirac delta of x is 0 both for x equal to 0 as well as for x not equal to 0. That is, it is 0 always. Now let us take derivative with respect to x, and this gives d dx of x delta of x as the left hand side, and the right hand side is d dx of 0, which obviously is 0. So the left hand side is split up into two terms, the first term being x into ddx of delta of x plus delta of x multiplied by ddx of x equal to 0. And ddx of x is unity, while let us designate ddx of delta of x by delta prime of x. So prime indicates first derivative. So we can write it as x into delta prime of x plus delta of x equal to 0. A slight rearrangement gives us x delta prime of x equal to minus of delta of x, and therefore we end up with delta prime of x equal to minus of delta x by x. So this is the first derivative of the Dirac delta function. Now let us put minus x for x, and we get delta prime of minus x equal to minus of delta of minus x divided by minus x. Now delta of minus x is just delta of x because Dirac delta function is an even function, and therefore we have delta prime of minus x to be equal to delta of x by x, it being equal to minus of delta prime of x as we have shown just now. So we end up with delta prime of minus x to be equal to minus of delta prime of x, their value being equal to, as we have shown, delta of x by x. And this is a very important result, and it shows that the first derivative changes in sign if we shift x to minus x, implying that the first derivative of Dirac delta function is an odd function. Let us now summarize some important results that we have got, and they are as follows. X delta of x is 0 always. Delta of minus x equal to delta of x. Delta prime of minus x is equal to minus of delta prime of x, and that value is delta of x by x. Now since delta of minus x is equal to delta of x, Dirac delta function is an even function, but the first derivative is an odd function.